All right. So let's take the next 5-10 minutes to do a quick recap on week one. Okay.
Yeah, well,
So
great.
okay. So again, just to talk about the exam. The exam which we're preparing for is AZ-900. It's going to cost you about $99, $100 to write the exam. It's going to measure three main domains. We have already covered the first domain, which is the cloud concepts, about 25% to 30%. This week, we're going to cover the second domain, which has to do with architecture and services. It's going to cover the bulk of it, which is 35 to 40%. Architecture, again, is going to tell you about the physical things that make up Azure and how you manage them. So physical infrastructure and management infrastructure. And the services, like I pointed out earlier, those three main services: compute services, networking services, and the storage services. Once we've taken care of these first 2 weeks, the third week, we start looking at security, management, governance, and then the final week, we'll do a little bit of review and recap, practice, and you're good to go. So again, it doesn't really score you over 100%. It has about 60 multiple choice questions to be done in, maybe 50 multiple choice questions to be done in 60 minutes. And I'll give you a lot of examples, a lot of questions, a lot of practice. So by the time you get to it, you must have tried at least 3 times so that you're comfortable. Those questions are basic. You already know the content, no matter how they twist it. It's multiple choice. You easily get your 700 out of probably 1,000 or 1,200. So domain one, we've covered it, all of it. As you can see, it's highlighted in green. We also did benefits of cloud service. I forgot to highlight that. So yeah, we're all done with that. With domain one now, we have to dive into domain two, which is going to talk about architectural components. And then later on today as well, we'll do part of this. And finally, tomorrow we'll get to complete networking, and storage will be done on Monday. So week one recap, like I said, a few things about the language of computing. So we described a stable and dependable cloud computing and the ability for you to adapt to changes in resource demand and user base and application and so on. So looking at these words out here, if you feel comfortable, you can pick any word and give me a description of what you think it is. I can start with high availability. High availability makes sure that even if one system goes down, the other system is up and running because it's in a different region. So you can have your computers operating or your servers running on the East Coast and another one running on the West Coast. If there's a catastrophe in the East Coast, the one on the West Coast is still running, so your business is still up and running. Now, scalability has to do with if you say you created a website that you want to target just Africans, and then it becomes very popular. Now it's targeting Africa and Europe. Now you have more people coming in. There's a lot of traffic. It's scalable because it can automatically reproduce and have you more servers to accommodate that traffic. We talked about two types of scalability. You can scale up and down, which is vertical. That's by increasing the size, maybe the size of the RAM or the size of the disk or the size of the storage per se. Or you can increase it horizontally, in and out, right? In that case, you're adding more instances of, say, the virtual machine or whichever resource. And we also talked about disaster recovery. Okay, so if there's a, say, for one reason or another, something like Turkey, unfortunately, if we had servers in Turkey and they all went down during the earthquake, then the other servers are going to be able to back up, and you can also recover your data from there. Fault tolerance, the same thing. Elasticity, you can be able to expand and retract as you need. Agility is very important. Agility, again, has to do, like those who are into Scrum. Agile mindset means quick. So you can get your website up and running quickly. You can get your system up and running quickly. You don't have to go to the market to buy hardware and set it up, find somebody to come and configure it, and if it goes down and so on, if you have no lights, no power, and all whatnot. So those are the benefits of cloud computing. All right. So what questions do you have with the language of cloud computing so far?
Look at scalability and elasticity. Like they don't seem to be kind of competing or how they operate, because it all depends. I mean, they all seem to talk about how you could increase the size and reduce, retract and expand.
That is very true. They seem very, very similar. I personally think that way too. But again, scalability, remember, scalability has to do with scaling up and down, in and out. Elasticity is just that you can expand. For instance, if you look at on-premises network, having everything on your premises, you can be able to decide to have some on the cloud so that if you run out of resources, you can go ahead and use the cloud resources and come back. So it's not really scaling in that case. It's always there available, but you just use what you need. The scalability, you get to pay only for what you use. So that's a very good question. I'll probably have to find a better way to clarify the difference between elasticity and scalability, but I don't think you'll see them side by side per se. It's because they're very, very similar if you look at elasticity and scalability.
And scalability goes, sorry, go ahead.
No, go ahead. You're saying scalability.
So it goes like to the direction of having that vertical and horizontal adjustments, right?
Yes. Yeah.
And the horizontal adjustment also kind of, I don't use the word synonym, but also applies to containerization, kind of.
Exactly, yeah. Yeah, so again, scalability, elasticity, I think they're interchangeable. But, scalability is being able to add and remove, right? Regardless of whether it's hardware or software. But elasticity is having that automaticness, or should I say automatically scaling up and down, not necessarily doing it manually. So the difference is just the level of automation per se. Does that make sense?
Yeah, it makes sense. Okay.
Yeah, so if you have to automatically go in and add, that's fine. But if you want it to be elastic, remember, think about wearing your elastic pants. It automatically adjusts to your waist size. But you can also wear a belt. The belt will be scalable because you can change the belt hole to be tighter or smaller or bigger and so on. That one you have to do it manually.
Okay.
Makes sense?
Yeah, makes sense.
Awesome. Very good question. So a few things we also talked about. We talked about economics in the cloud. Most people use the cloud because it's very affordable. It's cheap. Okay. So we described the cost of computing being consumer based. Back in the days when you use the phone, you have to buy how many minutes or you buy how many text messages. You use it or you lose it before you finally got to this pay as you go method that you only pay for resources that you use. So that's what the cloud is all about. So rather than you having capital expenditure, where you have to have upfront amount that you spend to either build a house or buy a car, you're instead renting the services. So operational expenses. Obviously, I cannot type correctly. So OpEx is what you actually do with up computing. You're just paying for the resources that you use. Okay, so CapEx means capital expenses. And operational expenses is OpEx. So again, think about either, having your own personal car that you buy, you put gas, you do maintenance, or just having to take a taxi or Uber or Lyft, and then you can decide which one is advantageous for you. So we also talked about service models, cloud types. Okay, the cloud types that we talked about included infrastructure as a service. There you're just renting the hardware. Okay, they rent the hardware, you go ahead and configure, do whatever you need to do to it. Again, you might decide to have it on your premises, then it becomes private, which we'll talk about later. Or you can rent the platform. The platform includes the hardware and the operating system. So we'll talk a little bit about that as well today to figure out what the difference is between software, hardware, operating system. So operating system as the platform, because all your applications run on the operating system. So think about it as either infrastructure is having the land that you're going to buy. Operating system is buying somebody's house that they have already built and then getting to use it. And then software as a service is you're not buying the hardware, you're not renting the hardware and the software, you're just renting the space. You're just out there renting the apartment. You can move on to another apartment and so on and so forth. So again, this is software that is being utilized. Again, in all cases, you are the one responsible for the data that you put there. You're the one responsible for the type of devices that are going to access it. You're also responsible for granting access. If you decide that, okay, I want person A, B, and C to have access to this, you go ahead and set them up. But the company, be it Amazon for AWS or Microsoft for Azure or Google for Google Cloud Service, they are the ones responsible for the hardware all the time. They're the ones that are going to be updating the hardware, having patches done on it. You don't have to worry about maintenance of the hardware. That's all their job. Okay. except if it's on premises. If it's on premises, then you have to be the one taking care of all the maintenance per se. Does that make sense? So I believe that's a yes. Finally, we talked about different types of cloud services. Again, cloud services is just somebody else has their servers. We are using it to do whatever we need to do, whether it's to compute or to use networking power or to store information. So if we have decided that we are the only ones that are going to stay in this compound, that means it's your private compound. You be your fence, nobody is coming in. You have the gate person and so on. But if you're renting in an apartment complex, you cannot say nobody can come into the apartment complex. In that case, that's a public cloud. You come into the apartment complex like a hostel or a hotel. You go into your room, but all of you are using the elevator. All of you are using the front desk. All of you are using the reservation services and so on. But you have your dedicated area that is for you. So that's public and so on. Hybrid is using both, right? Being able to have the private and the public cloud in conjunction and one another. Meanwhile, multi-cloud would be having multiple houses, or should I say multiple apartments that you're renting in complexes. Okay, so you're using both Amazon Web Service, and maybe you're using Google Cloud Service for machine learning, and you're using Amazon Web Service for files sharing, and maybe you're using Azure Cloud Services to host your website. So all three services, you're using it for different things that need to be done for your company. All right. So that's that. The next part we have to talk about